In this tutorial I'm going to explore MLFlow. MLFlow is an open-source platform designed to manage the machine learning lifecycle, including experimentation, reproducibility, and deployment. It helps data scientists and ML engineers track experiments, package code into reproducible runs, and deploy models easily. In basic data science projects, often experiments are tracked within spreadsheets or manual notes, making really hard to share the work in a collaborative environment. MLFlow solves all these problems. It helps you keeping track of what combinations of hyperparameters, models, and data versions performed best. It stores models with version control and lifecycle management, allowing proper governance, collaboration, and promotion of models in production environments. Let's first of all see how to install MLFlow. We can create a local environment with Python venv MLFlow. We have then to activate the environment. We can now simply install MLFlow with pip install MLFlow. If we want to use the env in Jupyter, we have to install ipkernel with pip install ipkernel. Add the current env as kernel. Python ipkernel install username MLFlow displayname MLFlow. Further information can be found on MLFlow official page. Once MLFlow is installed, we can use it within our Python project. We have to run it, in our case locally. This can be done by running from command line the MLFlow server command. MLFlow server host 127.0.0.1 port 8080. We need to specify the local host as well as the port. After that the server is started, we can run our notebook. In this notebook we're going to create a synthetic dataset for a regression problem. In my case I've already run it before the video to gain some time. The synthetic dataset can be created with the function make_regression from sklearn. We can specify as parameters the number of samples in the datasets, the number of features, the noise, and a random state for reproducibility. We can do a quick analysis of the created dataset with a pair plot. A pair plot is a grid of plots that shows scatter plots for each pair of features, histograms, or KDE plots, on the diagonal to show distributions of individual features. A kernel density estimate, KDE, plot is a method for visualizing the distribution of observations in a dataset, analogous to a histogram. KDE represents the data using a continuous probability density curve in one or more dimensions. The purpose of a pair plot is explore feature relationships, see if there's correlation or pattern between features and target. Detect multicollinearity, strong linear relationships between input features can be spotted. Check for nonlinear patterns, useful for deciding model types. Find outliers or clusters. From the above plot we can spot that some of the features have a linear relation with the target variable. In the next cell we're going to define several classical ML methods that can be used for regression as linear regression, ridge regression, random forest, and SVR, support vector regression. Then we can define some options in MLFlow as the experiment name and the visualization URL. We can now iterate over each method and fit the data. Once the predictions are done we can calculate some metrics as the mean squared error as well as the R2 metrics. We can log further information about the model thanks to MLFlow methods. We can log the model name, the metrics, and the model path. Finally, we just print the calculated metrics. After each logging, we will have the link to the model on MLFlow printed as well as a link to all the models. If we go to MLFlow, we can observe the 4 tested models. We can check all the model and sort by a specific metric. Additionally, we can select all the models and compare them. We can select different fields and compare how the model performed on each specific metric. Let's go to the linear regression model, for example. We can observe all the model details as creation date, user, experiment ID, experiment duration. Other windows show reported parameters or reported metrics. Additionally, we can register the model in order to keep track of its evolution and be able to recover later the desired version. If we jump back to our notebook, we can see how to load the model that we have previously registered. We can simply specify the path of the model and load it with load_model function. On the opposite, to register a model, we can use the function log_model. If the model already exists with version n, it will be registered with version n+1. In this short video, we have learnt how to keep track of a data science regression problem thanks to MLFlow. MLFlow is great to keep track of the hyperparameters, models, and data versions performed best, making easy to share projects among different users. I hope you have enjoyed the current video and see you soon for more content.